Automated driving will transform the notion of mobility. Commuting hours will be enjoyable and safe experiences. And our environment will benefit from decreased carbon emissions. This groundbreaking EU-funded project leverages on the 5G communication technology to connect all vehicles and facilitate their cooperation, including connected and automated vehicles in the communications network. With a dedicated 600-kilometer corridor between Munich, Innsbruck and Bologna, 5G Carmen will promote a cooperative transportation system which can be replicated throughout the EU in liaison with other activities on 5G corridors. 5G coverage has already been deployed along the borders of Italy, Austria, Germany, which accommodates 80,000 daily transits. Full 5G coverage is planned for 2025 and will pave the way for the creation of a fully equipped 600-kilometer 5G smart vehicle corridor. To support its 5G Carmen use cases on connected and automated driving, 5G Carmen has deployed an architecture where vehicles can communicate with each other through vehicle-to-vehicle and vehicle-to-network communication technology, exploiting the 5G technologies deployed for the project. Through the 5G network and directly among vehicles, data collected by vehicles can be delivered to the different services hosted on the Mobile Edge Computing (MEC) platforms. These platforms have been deployed with dedicated connections to minimize latency, thus bringing services close from a communications point of view to their users. The services in the MEC platform interact to provide the cooperative and connected autonomous mobility use cases piloted in 5G Carmen. These services are managed through an edge orchestration platform developed inside the project that also handles service continuity by speaking with other MECs in neighboring countries. In this way, services running on MEC of neighboring countries can be coordinated, and information collected on one side of the border can reach the other side through 5G connectivity, allowing service continuity across countries. Moreover, the 5G mobile networks in the three countries have been enhanced with some evolved features, introducing fast network reselection to reduce the communication gap when crossing the border, and local breakout to keep communication latency under control, also when users are in roaming. Lane merging is a cooperative operation among the vehicles, done every time two lines merge into one. 5G Carmen has deployed a centralized service to coordinate lane merging, optimizing it to avoid congestion or even accidents. In order to have all necessary information for the system to work, an onboard software inside the car obtains several information and then sends it to the MEC via a 5G modem. In our case, the data is their speed, position, and the blinker status. After reaching the 5G node of the mobile operator, data will travel to the MEC. We have 3 MECs, one per country. Each one consists of several elements that allow the coordination of the traffic. Advanced Message Queuing Protocol Broker allows fast and reliable communication between cars and MEC. It permits messages to be delivered to multiple services. The Service of Local Dynamic Map, SLDM, processes the received messages, combines them per geographical zone using quad-tree approach, and summarizes the requests of all relevant cars. The maneuvering service is the protocol that, with the info received previously, calculates the next actions for every car in the area. It coordinates their velocities, ensures that correct distance is kept, and allows space for a possible merge. The response router gets the coordination information and it separates it in messages for each car. Afterwards, the AMQP broker handles the sending of all messages to the receptive cars. The message arrives now to the cars involved in a merging. The speed from the 2 cars already in the highway is modified according to the information received, and the third car can safely merge in the most optimized way. This service allows a high reliability for zero-error lane changing and is capable of handling high vehicle density, The cooperative lane merging assist is but only one of the possible uses for this system. In 5G Carmen architecture, connected vehicles share their information with both CV2X direct communication and using 5G technology that connects them with the MEC platforms deployed in the 5G Carmen infrastructure. Services in the MEC can merge the information collected from all connected vehicles with additional data information provided by road operators about traffic or specific road conditions, building a detailed and reliable representation of the context around each car. Through 5G, this context can be delivered to connected vehicles to extend their perception and provide awareness of events that are still beyond the visibility of a vehicle sensor. This follows a core principle of autonomous driving. In high levels of automation, a car needs to see beyond other cars. 5G connectivity, with 5G Carmen, is the solution to see beyond what sensors and individual drivers see, ensuring comfortable travel in any situation. For example, car following with the so-called extended perception ensures smooth speed adaptation in case of slowdown maneuvers or cut-in by other vehicles. 5G Link is supported by CV2X direct connectivity to ensure redundant communication between cars. In another example, when an emergency vehicle approaches, it can alert all preceding vehicles by communicating with services in the MEC. 5G Carmen promptly informs all road users along the corridor through its 5G infrastructure. Cars can automatically check free road space and change lanes, giving way to the emergency vehicle as it approaches. The 5G Carmen project will contribute to the evolution of connected and automated mobility in Europe. The 5G cellular network infrastructure, the 5G direct communication technology, and automated driving will transform the future of cooperative transport, making the EU a leader in the reinvention of global transportation systems.